What if I told you that everything you've ever been taught about the size of the universe is wrong? Not slightly off, not just outdated, but fundamentally, catastrophically wrong. The James Webb Space Telescope, humanity's most powerful eye in the cosmos, just shattered our understanding of reality itself. And what it found is so mind-bending that physicists are quietly having existential crises in universities around the world right now. Here's the thing that'll make your brain hurt. Webb didn't just look far into space. It looked too far. It saw things that shouldn't exist. Galaxies that are impossible. Structures so massive, they violate the laws of physics as we know them. And in doing so, it revealed something terrifying and beautiful about the true nature of our universe. Picture this. You're standing in a room you think is 10 feet wide. You've measured it. You've walked it. You know this room. Then someone hands you a pair of special glasses, and suddenly you realize the walls you've been seeing, they're not walls. They're curtains. And behind those curtains, an endless cathedral that stretches so far in every direction that the concept of measurement becomes meaningless. That's what just happened to humanity. We thought we knew the universe. We had our 93 billion light-year observable bubble. We had our models, our equations, our confidence. And then Webb looked through the curtain, and what it saw has forced us to rewrite the most fundamental chapter in the book of existence. In the next 3.5 hours, I'm going to take you on a journey that will permanently change how you see reality. We're going to explore impossible galaxies, forbidden zones of space-time, and a discovery so profound that when you understand it, really understand it, you'll never look at the night sky the same way again. But before we dive into the cosmic rabbit hole, do me a favor. Hit that like button right now. Subscribe to this channel. And drop a comment telling me, what country are you watching from? And what time is it there right now? Because what we're about to discuss transcends borders and time zones. This is a revelation for the entire human species, and I want to know where in our small corner of this incomprehensibly vast universe you're listening from. Let's begin with what we thought we knew. For decades, we've been operating under a comfortable assumption. The observable universe, the sphere of space from which light has had time to reach us since. The Big Bang is roughly 93 billion light-years in diameter. That number gets thrown around in documentaries, textbooks, and science articles like it's settled fact. And for the most part, it was. Until now. But here's where things get interesting. That 93 billion light-year figure? It's based on what we can theoretically observe. It's the cosmic horizon. The edge beyond which light hasn't had enough time to reach us in the 13.8 billion years since the universe began. Think of it like standing on a boat in the ocean. Your horizon is determined by how far you can see before the Earth's curvature hides everything beyond. The observable universe is our cosmic horizon. But here's the twist that most people don't realize. The observable universe and the actual universe are not the same thing, not even close. Imagine you're in a massive football stadium, but all the lights are off except for a small flashlight you're holding. You can only see as far as your flashlight beam reaches. Does that mean the stadium only exists within your beam of light? Of course not. The rest of the stadium is still there, packed with seats and structure and space, whether you can see it or not. That's the universe. What we observe is just our little flashlight beam in an arena of unknown and possibly infinite size. Now, before Webb, we had theories about what might exist beyond our observable bubble. Maybe the universe extends forever in all directions, infinite and endless. Maybe it curves back on itself, like the surface of a sphere, finite but without boundaries. Maybe there are other bubble universes beyond ours, separate realities we could never touch or observe. These were all interesting philosophical discussions, mathematical exercises, cosmic what-ifs. But Webb didn't give us philosophy. Webb gave us data. Hard, concrete, photograph it and measure it data. And that data is telling us something that challenges the very foundations of modern cosmology. Let me introduce you to the problem, the crisis, really, that Webb has created. It's called the impossible early galaxy problem, and it's keeping cosmologists up at night. In 2022, when Webb began sending back its first deep field images, astronomers were excited to see what the early universe looked like. They expected to find small, primitive galaxies. Baby galaxies. A cosmic equivalent of simple single-celled organisms from the dawn of life on Earth. After all, these galaxies formed just a few 100 million years after the Big Bang. They should be tiny, irregular, still in the process of coalescing from primordial gas clouds. Instead, Webb found monsters. Massive, mature, fully formed spiral galaxies. Galaxies with complex structures, organized disk patterns, even central bulges indicating they'd already undergone billions of years of evolution. But here's the problem. They existed at a time when they'd only had a few 100 million years to form. It's like expecting to find a newborn baby and instead discovering a 30-year-old Olympic athlete with a PhD. Dr. Ivo Lob from the Swinburne University of Technology in Australia was one of the first astronomers to identify these impossible galaxies. He and his team discovered 6 massive galaxies dating to just 500 to 700 million years after the Big Bang. These galaxies were so large and so evolved that, according to our models, they shouldn't exist. The universe simply hadn't had enough time to build them. Think of it like this. Imagine you're baking a cake, and the recipe says it needs to be in the oven for 1 hour to fully rise and cook. Now imagine opening the oven after just 10 minutes and finding a perfectly baked, fully decorated, 3-tier wedding cake. You'd question everything. Did someone sneak it in there? Did time work differently inside the oven? Is your understanding of baking fundamentally broken? That's where cosmology is right now. Our recipe for galaxy formation, our models for how gravity pulls matter together, how stars ignite, how structures evolve, says these galaxies need billions of years to form. But they appeared in hundreds of millions. The math doesn't work. The physics doesn't work. And it gets worse. Much worse. Dr. Mike Boylan-Kolchin at the University of Texas ran simulations based on our current understanding of the lambda-CDM model. That's the standard model of cosmology that describes the universe's expansion. Dark matter, dark energy, the whole cosmic framework we've built over the past century. His simulations showed that the probability of finding even one of these massive early galaxies is astronomically low. Finding 6 of them? The odds are so small, they're essentially 0. But Webb didn't just find 6. As more data came in throughout 2023 and 2024, astronomers found dozens, then hundreds. And these weren't isolated cases. They were everywhere Webb looked in the early universe. It's not an anomaly. It's not a fluke. It's a pattern. And patterns demand explanations. So what's going on? How do we explain galaxies that shouldn't exist? There are really only a few possibilities, and each one is more reality-shattering than the last. Option 1. Our measurements are wrong. Maybe we're miscalculating the distances to these galaxies, misinterpreting their redshift data, somehow getting fooled by cosmic illusions. But here's the problem with that. Multiple independent teams using different methods have all confirmed the same results. These galaxies are exactly where and when they appear to be. The measurements are solid. Option 2. Our understanding of galaxy formation is wrong. Maybe galaxies can form faster than we think. Maybe there are processes we don't understand, mechanisms that can compress millions of years of evolution into mere moments. This would require rewriting huge sections of astrophysics, but it's possible. Scientists are exploring this right now. But here's option 3, and this is where things get truly mind-bending. Maybe the universe is bigger, older, or fundamentally different than we ever imagined. Maybe our entire cosmic timeline is wrong. Maybe the Big Bang wasn't the beginning. Maybe there was something before, something that seeded the universe with structure and matter in ways we're only now beginning to glimpse. And this is where the true size of the universe becomes relevant. Because if the universe is vastly larger than we thought, if what we observe is just a tiny fraction of an incomprehensibly larger whole, then the rules change. The timeline changes. Everything changes. Here's what will blow your mind. Some cosmologists are now seriously proposing that we might be living in a universe that's not 13.8 billion years old, but possibly trillions of years old. A universe that went through cycles of expansion and contraction long before our Big Bang. A universe where what we call the beginning was just the latest in an endless series of cosmic renewals. Dr. Paul Steinhardt at Princeton University has been developing a model called the cyclic universe theory for years. And Webb's discoveries? They're making his once fringe ideas look increasingly plausible. In this model, the universe bounces between expansion and contraction eternally. What we call the Big Bang was just the most recent bounce. And if that's true, then the structures Webb is seeing aren't impossibly young. They're echoes of previous cycles, remnants of a far older cosmos than we ever dared imagine. Let that sink in for a moment. Everything you've been taught about the beginning of time, the birth of space, the origin of everything, it might all be wrong. Not slightly wrong, fundamentally, completely, cosmically wrong. And we're just getting started. Now, before we go deeper down this rabbit hole, I need you to understand what we're actually seeing when Webb looks at the distant universe. Because there's a beautiful paradox at the heart of astronomy that most people never fully grasp. When you look at distant objects in space, you're not seeing them as they are now. You're seeing them as they were. Light travels at a finite speed, about 186,000 miles per second, or roughly 300,000 kilometers per second. That sounds fast, and it is the fastest thing in the universe. But space is so vast that even light takes time to traverse it. When you look at the sun, you're seeing it as it was about 8 minutes ago. That's how long it takes light to travel the 93 million miles from the sun to Earth. If the sun exploded right this instant, we wouldn't know for 8 minutes. We'd still see it shining peacefully in the sky, blissfully unaware that our star had already died. When you look at the nearest star system, Alpha Centauri, you're seeing it as it was 4.3 years ago. Look at a star 100 light years away, and you're seeing light that left that star in 1926. You're literally looking at the past. Now scale that up. Way up, but high. The galaxies Webb is observing aren't 100 light years away. They're not even 100,000 light years away. They're billions of light years distant. When Webb captures an image of a galaxy that existed 13.5 billion years ago, it's seeing light that's been traveling through space for 13.5 billion years. That galaxy doesn't look like that anymore. It's evolved, changed, possibly even died, and dispersed back into cosmic gas. But we're seeing its ancient light, its cosmic ghost, frozen in time from an epoch when the universe was just an infant. This is called look-back time, and it's one of the most powerful tools in astronomy. Every time we look deeper into space, we're also looking backward in time. Webb isn't just a telescope, it's a time machine. But here's where the paradox emerges, and it's crucial to understanding what Webb has discovered about the true size of the universe. If you could somehow instantly teleport to one of those distant galaxies, Webb is observing the ones that existed 13.5 billion years ago, and you look back at where Earth is now, what would you see? You'd see the location where our galaxy will someday form, but as it existed 13.5 billion years ago. You'd be looking at our ancient past, just as we're looking at theirs. Now here's the twist. From that galaxy's perspective, Earth is 13.5 billion light years away. But from Earth's perspective, that galaxy is also 13.5 billion light years away. So the total distance between us and them is, what? 27 billion light years? Not quite. And this is where the true weirdness of cosmic expansion comes in. See, space itself is expanding. Not just the objects in space moving apart like shrapnel from an explosion, though that's happening too, but the actual fabric of space is stretching, growing, expanding between every point in the universe. It's like baking raisin bread. As the dough rises, the raisins move apart, not because they're traveling through the dough, but because the dough itself is expanding between them. This means that a galaxy we observe, as it was 13.5 billion years ago, when its light first began its journey to us, is no longer 13.5 billion light years away. It's much farther now. Because in the time it took that light to reach us, space itself has been expanding, carrying that galaxy even farther away. Current calculations suggest that same galaxy is now roughly 46 billion light years away from us. And that's just in one direction. Do the same calculation in every direction, and you get that 93 billion light-year diameter for the observable universe. Not because light has traveled 93 billion light years. It can't. The universe is only 13.8 billion years old. But because space has been expanding the entire time, light has been traveling. Still with me? Good. Because now we get to the part that'll really bake your brain. Dr. Katie Mack, a theoretical astrophysicist at North Carolina State University, explains it like this. The observable universe is just our cosmic horizon. It's the limit of what we can currently see, based on how long light has had to travel and how much space has expanded in that time. But there's absolutely no reason to think the universe stops at our horizon. In fact, all our best models suggest it continues far, far beyond what we can observe. How far? That's the trillion-dollar question. And it's the question Webb is now forcing us to confront with unprecedented urgency. Some models suggest the universe could be just slightly larger than what we observe, maybe a few times bigger. Others suggest it could be infinite, extending forever in all directions, with no edge, no boundary, no end. And if that's true, then out there, beyond our cosmic horizon, there are literally infinite galaxies, infinite stars, infinite planets, infinite copies of you reading infinite versions of this script. That's not science fiction. That's a serious consequence of an infinite universe with quantum mechanics. If space is truly infinite, and matter is distributed even semi-randomly, then every possible configuration of atoms must occur somewhere, including exact duplicates of Earth, of you, of this moment. In fact, in an infinite universe, there are infinite copies of you, all having slightly different experiences. But Webb's discovery suggests something even stranger might be happening. Those impossibly massive early galaxies, the ones that shouldn't exist according to our timeline, what if they're not actually early? What if our cosmic horizon is wrong? What if the universe is so much larger than we thought that these early galaxies had plenty of time to form, but from a perspective we haven't yet considered? Here's what I mean. Imagine the universe isn't 13.8 billion years old. Imagine it's 100 billion years old, or a trillion, or eternal. In that scenario, the early galaxies Webb sees aren't early at all. They're mature galaxies in a cosmos far older and larger than we've imagined, and our observations of them have been distorted by effects we don't yet understand. Dr. Rajendra Gupta at the University of Ottawa published a paper in 2023 proposing exactly this. He suggests that if we account for certain effects of cosmic evolution, then our current models ignore things like the changing nature of physical constants over cosmic timescales, or the possibility that light tires over extreme distances in ways we haven't detected. The universe could be as much as 26.7 billion years old, twice our current estimate. Is he right? The jury's still out. Most cosmologists are skeptical. But here's what's significant. These ideas are being taken seriously now in ways they never were before. Because Webb has created a crisis that demands new thinking. And the implications are staggering. If the universe is twice as old as we thought, then the scale of everything changes. The cosmic horizon expands. The structures we see had more time to form. The impossible becomes possible. But it also means our fundamental understanding of cosmic evolution, the expansion rate, the nature of dark energy, all of it needs revision. Every decade or so, astronomy experiences a revolution, a moment when our instruments become powerful enough to see something that challenges our theories. The invention of the telescope showed us moons around Jupiter and phases of Venus, shattering the Earth-centered model of the cosmos. The discovery of cosmic redshift revealed the universe was expanding, destroying the static eternal universe model. The detection of cosmic microwave background radiation confirmed the Big Bang theory and eliminated rival models. Webb is giving us one of those moments right now. And unlike previous revolutions, which refined our understanding or chose between competing theories, this one is threatening to upend the entire framework. Because here's the terrifying possibility that's emerging from the data. What if the universe isn't just bigger than we thought? What if it's bigger in ways we literally can't comprehend? What if the very concept of size breaks down at cosmic scales, and we're trying to measure something that transcends measurement? Stick with me. We're about to go even deeper. Let's talk about infinity for a moment, because it's not what you think it is. And understanding infinity, really understanding it, is crucial to grasping what Webb might be revealing about the true size of the universe. When most people hear infinite, they think really, really big. Like imagine the biggest thing you can, then multiply it by 1 billion, then multiply that by 1 billion. That's infinity, right? Wrong. That's still not even close to infinity. You could multiply by 1 billion, then 1 trillion, then invent new numbers bigger than anything that's ever been conceived, multiply by those, repeat the process a googol times, and you still wouldn't have approached infinity. You just have a really big finite number. Infinity isn't a number. It's a concept. It's the state of being endless, boundless, without limit or conclusion. And here's what will blow your mind. There are different sizes of infinity. Some infinities are literally bigger than other infinities. Think of it like this. There are infinite whole numbers. 1, 2, 3, 4, 5, and so on forever. That's an infinite set. But there are also infinite decimal numbers just between 0 and 1. 0.1, 0.01, 0.001, and infinite more. That's also an infinite set. But which infinity is bigger? Mathematician Georg Cantor proved in the 19th century that the infinity of decimals is actually a larger infinity than the infinity of whole numbers. You can't create a one-to-one correspondence between them. There are, in a very real mathematical sense, more decimals between 0 and 1 than there are whole numbers extending to infinity. Your brain should be hurting right now. That's normal. Now apply this to the universe. If the universe is infinite in spatial extent, if it just keeps going forever in all directions, that's one kind of infinity. But if the universe is also eternal in time, if it has existed forever into the past and will exist forever into the future, that's another dimension of infinity. And if we add in quantum mechanics, which suggests that every quantum event splits reality into multiple branches, then you've got infinity multiplied by infinity multiplied by infinity. We're talking about levels of infinity that make the concept of size completely meaningless. But here's where Webb comes in with a plot twist. Because the telescope isn't just revealing that the universe might be bigger than we thought. It's revealing structures and patterns that suggest the universe might be organized in ways that transcend our dimensional thinking. In 2023, astronomers using Webb data discovered what they're calling the Big Ring. It's a massive structure in the distant universe. We're talking about a ring of galaxies that's roughly 1.3 billion light years in diameter. To put that in perspective, our entire Milky Way galaxy is about 100,000 light years across. This ring is 13,000 times larger. Dr. Alexia Lopez from the University of Central Lancashire discovered it. and her reaction tells you everything you need to know about how shocking this find was. She said the structure was not compatible with the cosmological principle, the fundamental assumption that the universe is roughly uniform at large scales. The big ring is too big, too organized, too structured to exist according to our understanding of how the universe should look. But wait, there's more. In the same region of space, there's another massive structure called the giant arc. It's even larger, 3.3 billion light years across. And here's the kicker. These two structures appear to be related, part of some larger cosmic architecture we don't understand. Think of it like this. Imagine you're an ant crawling on a massive structure. From your perspective, you just see the local terrain bumps, grooves, textures. But if you could zoom out far enough, you'd see you're actually crawling on the face of an enormous statue, with eyes and a nose and a mouth, all made of the same material you're walking on. The structure was there all along, but you couldn't see it until you got the right perspective. That's where we are with the universe. For decades, we've been assuming that at large enough scales, the universe is basically uniform, smooth, homogeneous, just cosmic soup spread evenly in all directions. But Webb is showing us structures, rings, arcs, filaments, walls that suggest there's an architecture to the cosmos, a pattern, an organization that extends across scales so vast we can barely comprehend them. And if there's a pattern, that means the universe isn't random. It means there are rules, structures, organizing principles operating at scales we've never before observed. And that changes everything. Dr. Sabir Sarkar from Oxford University has been arguing for years that the cosmological principle, the idea that the universe is uniform at large scales, might be wrong. He's analyzed cosmic microwave background data, galaxy distributions, and supernova observations, and he keeps finding evidence that the universe has preferred directions, asymmetries, large-scale flows that shouldn't exist in a truly uniform cosmos. For a long time, his ideas were considered fringe, interesting, but probably just artifacts of incomplete data or measurement errors. But now, with Webb finding these impossible structures, Sarkar's ideas are getting a second look. Because if he's right, if the universe isn't uniform, then our entire method of measuring its size and age falls apart. Here's why. All our measurements of cosmic distances, expansion rates, and the universe's age depend on assuming that what we see in our little corner of space is representative of the whole. We measure how fast galaxies are moving away from us, calculate the Hubble constant, the rate of universal expansion, and use that to work backward to figure out when everything was compressed into a single point. That gives us the Big Bang, the age of the universe, the size of the observable sphere. But what if our corner of the universe isn't typical? What if we're in a region that's expanding faster or slower than average? What if the structures Webb is finding indicate that the universe has zones, regions, domains with different properties? Then all our calculations are local measurements that don't scale up to universal truths. It's like being in a boat on a river and measuring the current. You might calculate that the water is flowing at 5 miles per hour and use that to estimate how far the river extends. But if you're in a narrow rapids section and a mile downstream, the river opens into a wide, slow delta, your measurements will give you wildly wrong estimates of the river's total length. You were measuring a local condition and assuming it was universal? We might be making the same mistake with the universe. And this brings us to one of the most unsettling implications of Webb's discoveries. We might not just be wrong about the size of the universe. We might be wrong about our place in it. For centuries, humanity has been on a journey of cosmic humility. First, we discovered Earth wasn't the center of the solar system. Then, we discovered the solar system wasn't the center of the galaxy. Then, we discovered our galaxy was just one of billions. Each step removed us further from any special cosmic position. But what if we've taken that too far? What if our assumption that we're in a perfectly average, unremarkable part of an utterly uniform universe is itself a form of bias. Think about it. If the universe has structure at the largest scales rings, arcs, walls, voids, then some regions are necessarily denser than others, more active than others, more conducive to galaxy formation and stellar evolution than others. If we happen to be in one of these special regions, not because we're divinely chosen, but just by random chance, then our observations from here won't tell us about the universe as a whole. It would be like an alien civilization that evolved in the Sahara Desert trying to understand Earth. They develop theories about planetary climates based on heat, sand, and drought, and they'd be utterly shocked when they finally sent the probe over the ocean and discovered that most of Earth's surface is covered in water. Their theories weren't wrong for the Sahara. They just weren't universal. Are we in a cosmic Sahara, developing theories that work locally but fail universally? Webb's impossible galaxies suggest we might be. Here's a thought experiment. Imagine the universe is like a vast ocean. The observable universe, our 93 billion light-year bubble, is like the water you can see from a submarine's porthole. Now you've been measuring the temperature, salinity, current, and pressure of that water, and you've developed sophisticated models of how oceans work based on what you observe. But what if, unbeknownst to you, your submarine is in the Gulf Stream, a warm current in a much larger, colder ocean? Your models would describe the Gulf Stream perfectly, but they'd fail catastrophically if you tried to apply them to the Arctic waters 1,000 miles away. You're not seeing the whole ocean. You're seeing one current within it, and you've mistaken the part for the whole. Now scale that up to cosmic proportions. What if the observable universe is just one current in a vast cosmic ocean? What if the laws of physics, the constants we measure, the expansion rate we observe, what if they're all local phenomena that vary across a universe so large that size becomes meaningless? Some cosmologists are starting to take this seriously. The idea is called multiverse theory, though that's actually a catch-all term for several different concepts. One version suggests that different regions of space might have different physical constants, different strengths of gravity, different values for the speed of light, different numbers of spatial dimensions even. These regions would be separated by vast distances or energy barriers, effectively making them separate universes, even though they're all part of the same cosmic fabric. In this model, we're not in the universe. We're in a universe, our local region with its particular set of physical laws. And there are countless other regions, other universes, beyond our horizon, each with their own properties. And here's the kicker. Webb might be giving us our first glimpse of the boundaries between these regions. Those impossible early galaxies. What if they're not early at all? What if they're galaxies from a neighboring cosmic domain where time flows differently, where matter condensed faster, where the laws are just different enough to make the impossible possible? I know what you're thinking. This sounds like science fiction. This sounds like wild speculation disconnected from evidence. But here's the thing, these ideas are coming from serious physicists, published in peer-reviewed journals, debated at major cosmology conferences. Because Webb has created a crisis, and when faced with a crisis, science has to consider every possibility, no matter how strange. Dr. Lavra Mersini-Houghton at the University of North Carolina has been developing mathematical models of what she calls the quantum landscape, the idea that the Big Bang wasn't a singular event, but a quantum process that created bubbles of space-time with different properties. Our universe is one bubble. But there are others, possibly infinite others, all emerging from the same underlying quantum field. Her models predict exactly what Webb is seeing, structures and galaxies that don't fit our timeline because they're being influenced by quantum effects from neighboring cosmic domains that we can't directly observe. The mathematics works. The predictions align with observations. It's not proven, but it's not crazy either. And if she's right, then asking how big is the universe is like asking how big is the number line. The question doesn't have an answer in traditional terms, because the thing you're asking about transcends the framework of your question. Let that sink in. The true size of the universe might be a question that can't be answered, not because we lack the technology or the data, but because the universe is so fundamentally vast, so beyond our conceptual capacity, that the very notion of size breaks down when applied to it. And we're about to go even deeper into the rabbit hole. Okay, let's take a step back and get grounded for a moment, because I want to make sure you're truly grasping the magnitude of what we're discussing. And to do that, I need to give you an analogy that makes the scale of this comprehensible. Think of it like this. Imagine you're a bacterium living on a grain of sand. Your entire universe, everything you can observe, everything you've ever experienced, is the surface of that grain. You've mapped it thoroughly. You understand its ridges and valleys. You've developed theories about how the grain formed, how old it is, what it's made of. Now imagine that grain of sand is on a beach, and that beach is on a coastline, and that coastline is on a continent, and that continent is on a planet, and that planet is in a solar system, and that solar system is in a galaxy, and that galaxy is in a supercluster, and that supercluster is in an observable universe, and that observable universe might be just one domain in an infinite multiverse. Each level is so vastly larger than the previous level that the ratio becomes almost meaningless. The observable universe is to a potential multiverse as your grain of sand is to all the beaches on all the continents on Earth. No, it's smaller than that. Infinitely smaller. That's where Webb's discoveries are leading us. Not just to a universe that's bigger than we thought, but to the realization that we might be so far removed from comprehending the true scale of reality that our entire framework for understanding it needs to be rebuilt from the ground up. But here's what's fascinating. Even as we're discovering how small and insignificant we are in the cosmic scheme, we're also discovering how remarkable it is that we can discover anything at all. The fact that you're a collection of atoms arranged in a specific pattern on a small rocky planet orbiting an average star in an unremarkable galaxy can contemplate the size and nature of the entire universe is perhaps the most astounding fact of existence. You are the universe becoming aware of itself. You are stardust that learned to think, to question, to build telescopes, and peer back through time to its own origins. In all the vast cosmic expanse Webb is revealing, that might be the rarest phenomenon of all. Now, let me tell you about something called the cosmological horizon problem, because it's central to understanding why Webb's discoveries are so revolutionary. Here's the issue. When we look at the cosmic microwave background radiation, the afterglow of the Big Bang that fills all of space, we see that it's remarkably uniform. The temperature is the same to within 1 part in 100,000 in all directions. Think about that. Regions of space separated by billions of light years. Regions that have never been in contact with each other, because light hasn't had time to travel between them in the age of the universe, somehow have exactly the same temperature. That shouldn't be possible. It's like finding that every grain of sand on every beach in the world is exactly the same size, even though the beaches have never interacted with each other. There's no mechanism for them to coordinate, no way for information to travel between them. Yet they're identical. This is called the horizon problem, and it's one of the biggest mysteries in cosmology. The standard explanation is something called inflation, the idea that in the first tiny fraction of a second after the Big Bang, the universe expanded exponentially fast, smoothing out any initial irregularities and creating the uniformity we observe today. Inflation theory works beautifully mathematically, and it makes predictions that have been confirmed by observations. But here's the thing. It's also kind of a cheat. We're essentially saying, we don't understand why the universe is uniform, so we're proposing that a process we've never observed, driven by a field we've never detected, made everything smooth in a time span so short we can't directly study it. It's not wrong necessarily, but it's unsatisfying. It feels like we're papering over a gap in our understanding rather than truly explaining it. And now Webb is making the horizon problem even worse, because those massive early galaxies, they're not just impossible because they're too big too fast. They're also too similar to each other. Galaxies separated by billions of light years that formed independently in different parts of the early universe somehow developed nearly identical structures. Same spiral patterns, same central bulges, same stellar populations. It's like the universe had a blueprint, a template it was following. But how? How does information propagate across cosmic distances faster than light to coordinate the formation of identical structures in causally disconnected regions? Dr. Paul Steinhardt, who I mentioned earlier, has been working on this problem for decades, and his cyclic universe model offers a potential solution. If the universe goes through repeated cycles of expansion and contraction, then the initial conditions of our current cycle aren't random. They're inherited from the previous cycle. The structures Webb is seeing might be echoes of patterns established trillions of years ago in a previous iteration of reality. It's a mind-bending idea, but it solves the horizon problem without needing inflation. It explains the uniformity without invoking invisible fields. And it suggests that the universe is far, far older than we've imagined. But even if Steinhardt is right, it doesn't tell us how big the universe is. Because in a cyclic model, the universe could still be infinite in spatial extent. It's just also infinite in temporal extent. Infinity times infinity. We're back to infinities stacked on infinities, and the human brain just isn't equipped to truly grasp that. Let me try another analogy. Imagine you're trying to measure the ocean, but you're an underwater creature that's never seen the surface. You can measure the depth below you. That's like measuring back in time toward the Big Bang. You can measure the distance to the sea floor beneath you. That's like measuring to the cosmic microwave background. You can measure laterally to your cosmic horizon. But you have no idea how deep the ocean is above you, or how far it extends beyond your horizon in every direction, or whether there's even a surface at all. You're making measurements within a space whose true dimensions are unknown and possibly unknowable. That's us. That's humanity right now. We're making measurements, building models, developing theories. And they work within our observable bubble. But we're increasingly realizing that our bubble might be an infinitesimally small part of something incomprehensibly larger. And Webb is showing us the edges of our bubble, the places where our models break down, the anomalies that don't fit, the impossible galaxies that whisper of a cosmos beyond our understanding. Here's what really gets me. Every time in history we've thought we'd figured out the cosmos, we've been wrong. Medieval scholars thought Earth was the center of creation. Renaissance astronomers thought the solar system was the entire universe. 19th century scientists thought the Milky Way was all there was. 20th century cosmologists thought 93 billion light years was the whole show. What makes us think we've got it right now? What makes us think that the observable universe is anywhere close to the full picture? The answer is nothing. We have no reason to think we're even close. And Webb is proving it by showing us things we can't explain, structures we can't account for, galaxies that violate our most fundamental models. So if the universe is vastly bigger than we thought, if it extends far beyond our ability to observe or even conceptualize, what does that mean for us? For you, sitting there listening to this script? For humanity? For Earth? That's what we're going to explore in the next section. And I promise you, the answer is more profound and more personal than you might expect. But before we continue, take a moment. Look around you. Think about the room you're in, the device you're listening on, the planet beneath your feet. All of this reality, exists within a cosmic context so vast that words fail to capture it, and you're part of it. You're not separate from the universe. You are the universe, expressing itself through human form, contemplating its own nature. Hold that thought. We're going deeper. Let's talk about what happens to meaning when you realize you're smaller than you ever imagined possible. Because this isn't just an intellectual exercise. This is existential. This is the kind of revelation that can shake your sense of self, your sense of purpose, your entire worldview. When Copernicus showed that Earth wasn't the center of the universe, it wasn't just astronomy that changed. Philosophy changed. Religion changed. Humanity's entire self-conception shifted. We went from being the central point of creation to being inhabitants of one planet among many. That was psychologically devastating for a lot of people. Then Darwin showed we weren't divinely created beings separate from nature, but products of evolutionary processes related to every other living thing on Earth. Another blow to human exceptionalism. Then Edwin Hubble showed that our galaxy was just one of billions, and the universe was far larger than anyone had imagined. We became even smaller, even less significant. And now Webb is doing it again. We're discovering that even our sense of cosmic scale is provincial, limited, almost charmingly naive. The universe isn't just bigger than we thought. It might be bigger than we can think. So what does that mean for you? For your life, your choices, your daily existence? Here's one response: nihilism. If we're that small, that insignificant, just brief sparks of consciousness in an incomprehensibly vast cosmos, then maybe nothing matters. Maybe all our struggles, our loves, our achievements, our civilizations, maybe it's all meaningless cosmic noise destined to be forgotten in the eons to come. That's one response. But I'm going to argue it's exactly the wrong response. Because here's what Webb is actually revealing. In a universe this vast, this complex, this gloriously intricate, the fact that you exist at all is cosmically improbable. The fact that atoms assembled themselves into structures complex enough to contemplate the universe is staggering. The fact that matter became aware of itself is perhaps the most significant event in cosmic history. Think about it this way. The universe spent billions of years as just gas and plasma, spreading out, cooling down, forming stars and galaxies through blind physical processes. It was spectacular, sure, but it was unconscious. It didn't know it was spectacular. It couldn't reflect on itself, couldn't ask questions, couldn't create art or music or mathematics. Then, on at least one small planet, and probably many others, the universe became conscious. It developed nervous systems and brains. It started looking back at itself, studying itself, understanding itself. You are that process. You are the mechanism by which the universe observes and comprehends its own existence. In all the vast cosmic expanse that Webb is revealing, all those billions of galaxies, all those impossible structures, all that space and time consciousness might be incredibly rare. Which means that you, by virtue of being conscious, by being able to think and feel and wonder, are participating in something extraordinary. Dr. Carl Sagan put it beautifully. We are a way for the cosmos to know itself. That's not poetry. That's literal truth. The atoms in your body were forged in the hearts of dying stars billions of years ago. You are literally made of stardust. And those atoms have organized themselves into a pattern that can look back at the stars. They came from and understand their own origin. That's not meaningless. That's the opposite of meaningless. That's meaning on a cosmic scale. But I want to go deeper, because there's another implication of Webb's discoveries that's even more profound. If the universe is vastly larger than we can observe, if there are potentially infinite galaxies beyond our horizon, then somewhere out there, in fact, in many places out there, there's other life. There has to be. The numbers demand it. Our galaxy alone has an estimated 100 to 400 billion stars. Many of those stars have planets. Many of those planets are in the habitable zone where liquid water can exist. And liquid water plus organic chemistry, plus a few billion years of time, seems to reliably produce life, at least based on the one example we know of, Earth. Now multiply that by the number of galaxies. At least 200 billion in the observable universe, possibly infinite beyond our horizon. The probability that we're the only life, the only consciousness, the only eyes looking back at the cosmos becomes essentially zero. We are not alone. We can't be alone. Not in a universe this vast. But here's the paradox. We might as well be alone. Because the distances are so great, the spaces between stars so vast, that even if our nearest cosmic neighbors are just 100 light years away, we'll never meet them. Not with our current technology. Not in our lifetimes, or our civilization's lifetime, or possibly ever. Light speed is the cosmic speed limit, and it's agonizingly slow when measured against the scale of space. Even our fastest spacecraft would take tens of thousands of years to reach the nearest star. We are islands of consciousness in an ocean of void, separated by distances so vast that communication would take generations, even if we could figure out how to communicate. So we're both insignificant and profoundly alone. That's the cosmic reality Webb is revealing. We're tiny, brief, isolated in space and time, and yet we can understand all of this. We can build telescopes that look back to the dawn of time. We can develop mathematics that describes the curvature of space-time. We can create art and music and literature that gives meaning to our brief existence. That tension between cosmic insignificance and meaningful existence is the human condition. And it's never been more apparent than it is now, as Webb shows us just how vast and ancient and strange the universe really is. But here's what I find hopeful in all of this. Every time we've expanded our cosmic horizon, we've also expanded our self-understanding. We've become more than we were. More thoughtful, more curious, more capable of wonder. When ancient humans looked at the night sky, they saw gods and myths, patterns that told stories about their tribes and their heroes. When medieval scholars looked up, they saw a divine clockwork, the evidence of a creator's plan. When Enlightenment scientists looked up, they saw mechanics and mathematics, natural laws governing celestial motion. And now, when we look up with Webb's eyes, we see, what? We see a cosmos so vast and strange that it defeats our attempts to fully comprehend it. We see galaxies that shouldn't exist, structures that violate our models, evidence that our entire cosmological framework might need revision. But we also see beauty. We see a universe that's more creative, more surprising, more gloriously weird than we ever imagined. And that's worth celebrating. Because the alternative a universe we fully understood, with no mysteries left, no surprises remaining, that would be boring. That would be dead. The fact that Webb can still shock us, still show us things we can't explain, means the universe is alive with possibility. It means there's still so much to discover, so much to learn, so many adventures left for future generations. And you get to be part of that. You right now are living through one of the great revolutions in human understanding. You're witnessing the moment when our species realized the cosmos is stranger and vaster than we ever dared imagine. That's not insignificant. That's historic. So when you feel small because of what Webb is revealing, remember this. You're small in size, but infinite in significance. You're brief in duration, but eternal in impact. Every choice you make, every person you touch, every idea you have ripples forward through time in ways you can't predict or control. You are not separate from the universe Webb is revealing. You are continuous with it. You are made of it. You are it, looking back at itself and marveling at what it sees. And that brings us to the next level of understanding, because there's something even stranger about the universe's size that we need to discuss. Something about the nature of observation itself, and how the act of looking might actually be creating what we see. Stay with me. This is where it gets really weird. All right, we need to talk about quantum mechanics for a moment. I know quantum mechanics is confusing and counterintuitive and makes people's brains hurt. But it's absolutely essential to understanding what Webb might really be showing us about the nature of the universe's size. Here's the basic weirdness of quantum mechanics. At the smallest scales, the level of atoms and subatomic particles, things don't exist in definite states until they're observed. An electron doesn't have a specific position and momentum. It exists in a superposition of all possible positions and momenta simultaneously, described by a probability wave. Only when you measure it does it collapse into a specific state. This isn't just weird. It's been experimentally verified thousands of times. It's how quantum computers work, how semiconductors function, how the sun fuses hydrogen into helium. It's fundamental to reality. But here's where it gets cosmically strange. If quantum mechanics governs the small-scale structure of reality, and the universe is made of quantum stuff, then does the universe itself exist in superposition until it's observed? Is reality all of space and time somehow dependent on observation to become real? This sounds like mystical nonsense, but it's a serious question that physicists have been wrestling with for a century. It's called the measurement problem, and it's never been fully resolved. Dr. John Wheeler, one of the most influential physicists of the 20th century, proposed something called the participatory anthropic principle. His idea was that the universe requires observers to become real, not in a magical or spiritual sense, but in a concrete physical sense. The act of observation collapses quantum superpositions, making specific outcomes definite. Without observers, the universe would remain in a fuzzy probabilistic state, a cloud of possibilities that never crystallizes into actual events. And here's where it gets really mind-bending. If observers are necessary to make the universe real, and observers only emerged billions of years after the Big Bang, then what was the universe doing for all those observer-less eons? Wheeler's answer: the observations we make now reach backward in time, retroactively determining the early universe's state. When Webb looks at a galaxy 13 billion light-years away, it's not just observing ancient light. It's participating in determining what that galaxy's quantum state was 13 billion years ago. Observation doesn't just reveal reality. It partially creates it, backwards through time. I told you it was weird. Now, most physicists think Wheeler went too far with this idea. There are other interpretations of quantum mechanics that don't require observers to play such a fundamental role. But here's what's interesting. We can't rule it out. And some aspects of quantum mechanics do seem to involve backward-in-time effects, like quantum entanglement and delayed choice experiments. So here's the question. When Webb looks deeper into space than any telescope before, when it observes galaxies and structures at the edge of the observable universe, is it just discovering what's there? Or is it, in some subtle quantum way, participating in determining what's there? If observation plays any role in collapsing quantum possibilities into concrete realities, then the size of the universe might depend, in part, on how much of it we observe. The more we look, the more we make real. The cosmic horizon isn't just a limit of observation. It might be a limit of realization. Think about it like this. Imagine a vast digital world, like a video game. The computer doesn't render the entire world at once. That would require infinite processing power. Instead, it renders what's on your screen, what you can currently observe. The rest exists as compressed data, as potentials that become actualized when you move your character to view them. Is the universe like that? Is the observable universe the part that's been rendered real by observation, while everything beyond our horizon remains in a compressed quantum state, waiting to be observed and therefore realized? I'm not saying this is definitely true, but it's a possibility we can't dismiss. And if it is true, then asking how big is the universe is like asking how big is an unopened box. The box has a certain size, sure, but what's inside exists in superposition until you open it and look. Webb is opening the box, and every time it looks deeper, it's making more of the universe definite, real, actualized. In this view, the universe grows not because it's expanding, though it is, but because we're observing more of it, collapsing more quantum possibilities into concrete realities. And here's the really trippy part. If this is true, then the future observations of future civilizations will continue to make the universe bigger, more real, more definite. The universe's size isn't a fixed property. It's an evolving one, growing as consciousness expands and observes more of the cosmic totality. Dr. Andre Linde, one of the founders of inflation theory, has suggested something similar. He proposes that the universe might be eternally self-creating through a process called eternal inflation, where quantum fluctuations continuously spawn new regions of spacetime, each potentially with different physical properties. In his model, the universe doesn't have a size in the traditional sense. It's more like a fractal, endlessly budding new universes from itself, with no absolute boundary or edge. And if quantum observation plays a role in determining which potential universes become real, then consciousness observers like us become co-creators of reality. Not in a new age, you create your own reality sense, but in a rigorous quantum mechanical sense. Observation participates in determining which of many quantum possibilities crystallizes into actual events. This has profound implications. It means that you, the person listening to this, are not just passively observing the universe. You're actively participating in making it real. Every observation you make, every measurement you take, every photon that enters your eye from a distant star, all of it is part of the process by which quantum possibilities collapse into concrete realities. You're not separate from the universe. You're a participant in its ongoing creation. Now, I need to be clear. This is speculative. Most physicists would say I'm overstating the case, reading too much cosmic significance into quantum mechanics. And they might be right. The relationship between quantum mechanics and cosmology is still being worked out, and we don't have definitive answers. But what we do have are questions. Deep, profound, reality-shaking questions. And Webb is making those questions more urgent, more pressing, more impossible to ignore. Because those impossible galaxies Webb found? Maybe they're impossible because we're using classical models to describe a universe that's fundamentally quantum. Maybe the early universe wasn't early in the sense we think. Maybe time itself is more fluid, more observer-dependent than we've imagined. Dr. Lee Smolin at the Perimeter Institute has been developing a theory called temporal naturalism, which suggests that time is more fundamental than space, and that the laws of physics themselves might evolve over cosmic time scales. In his view, the universe is a process, not an object. It's becoming, not being. And what it becomes depends, in part, on the observations and interactions of the conscious beings within it. If Smolin is right, then asking about the size of the universe is asking the wrong question. It's like asking about the size of a symphony while it's being performed. The symphony exists in time, not space. Its size is measured in duration and complexity, not meters or light years. Maybe the universe is like that. Maybe its true size is measured not in spatial dimensions, but in informational complexity, in the richness of its structure, in the depth of its interconnections. And maybe that size is growing, not because space is expanding, but because the informational content of reality is increasing as more interactions occur, more observations are made, more consciousness emerges. In this view, Webb isn't measuring the size of the universe. It's increasing it. Every observation adds to the total information, the total complexity, the total realized actuality of the cosmos. And the more we observe, the bigger in the sense of more informationally rich the universe becomes. This is where science and philosophy blur together, where hard data and speculative metaphysics dance around each other, neither quite able to pin the other down. And that's okay. That's where we are as a species right now, standing at the edge of understanding, peering into the darkness beyond, catching glimpses of something vast and strange that we're only beginning to comprehend. And you get to be part of that. You get to live in this moment of uncertainty and wonder, when the old answers have failed, but the new answers haven't yet crystallized. That's uncomfortable, but it's also exhilarating, because the universe is revealing itself to be stranger, more beautiful, more profoundly mysterious than we ever imagined. And every observation, every discovery, every impossible galaxy Webb finds is an invitation to expand our minds, to think more deeply, to wonder more fully. So when you look up at the night sky tonight, remember, you're not just seeing distant lights. You're seeing photons that have traveled for millions or billions of years to reach your eye. You're seeing the past, reaching out to touch the present. You're seeing the universe observing itself through you. And in some subtle quantum sense, you're helping to make it real. Let's shift gears now, because there's another aspect of Webb's discoveries that we need to explore. What the true size of the universe means for the possibility of other life, other civilizations, other conscious beings out there in the cosmic vastness. Because if Webb is showing us that the universe is far bigger than we thought, then the probability of life existing elsewhere increases dramatically. In fact, it might become not just probable, but inevitable. And that has profound implications for humanity's future. Here's the thing about life. As far as we know, it's chemistry. Complex chemistry, sure, with emergent properties like self-replication and metabolism and responsiveness to environment. But at its core, life is just atoms arranged in specific patterns, following the laws of physics and chemistry. And if that's true, then anywhere the conditions are right, liquid water, organic molecules, energy sources, a few billion years of time life should emerge. Maybe not intelligent life, maybe not technological life, but life of some kind, exploiting energy gradients and building complex structures. Earth wasn't special in its chemistry. We're made of the most common elements in the universe: hydrogen, carbon, nitrogen, oxygen. The organic molecules that form the basis of life: amino acids, nucleotides. Sugars have been found in meteorites, in comets, in the interstellar medium. The ingredients for life are everywhere. So if Earth isn't special chemically, and the observable universe alone contains hundreds of billions of galaxies, each with hundreds of billions of stars, each potentially with multiple planets, the numbers are staggering. Even if the probability of life emerging on any given planet is vanishingly small, say, 1 in a billion, the sheer number of planets means there should be billions of life-bearing worlds in the observable universe alone. And if the universe is vastly larger than what we observe, if it's infinite or close to infinite, then there aren't just billions of life-bearing worlds. There are infinite instances of life, including infinite instances of intelligent, technological civilizations. This is called the Fermi paradox, after physicist Enrico Fermi, who supposedly asked during a lunch conversation in 1950, "Where is everybody? If the universe is teeming with life, if civilizations should be common, then why haven't we seen any evidence of them? Why no radio signals, no megastructures, no obvious signs of cosmic engineering?" For decades, this paradox has puzzled scientists. We've proposed hundreds of solutions. Maybe life is common, but intelligence is rare. Maybe intelligence is common, but technology is rare. Maybe technology is common, but civilizations destroy themselves before they can expand into space. Maybe they're out there, but hiding from us. Maybe we're looking in the wrong ways, listening for the wrong signals. But here's what Webb's discoveries suggest. Maybe the universe is so unimaginably vast that even if civilizations are common, the distances between them are so great that contact is effectively impossible. We're not alone, but we might as well be, because the cosmic distances separate us more effectively than any prison walls ever could. Think about it. If the observable universe is 93 billion light-years across, and civilizations are randomly distributed throughout it, then even if there are millions of technological civilizations in the observable universe, the average distance between them might be millions or billions of light-years. At those scales, communication is pointless. By the time a message reaches another civilization, both the sender and receiver cultures might have risen and fallen countless times. And if the true universe is vastly larger than what we observe, then the isolation is even more profound. We might have nearest neighbors just beyond our cosmic horizon, but we'll never know they exist because light from their region hasn't reached us yet and never will, given the expansion of space. We are, quite literally, alone in our observable bubble. There might be infinite others out there, but the structure of space-time itself keeps us separate. Dr. Frank Drake, who developed the famous Drake equation for estimating the number of communicative civilizations in our galaxy, spent his life searching for signals from other worlds. He never found any. And in his later years, he suggested that maybe the silence isn't because civilizations are rare, but because the universe is designed in a way that keeps them isolated. It's a haunting thought. The universe is teeming with life, with consciousness, with beings asking the same questions we're asking, building their own telescopes, searching their own skies. But we're all separated by such vast distances that we'll never meet, never communicate, never even know of each other's existence. Each civilization is alone in its corner of infinity, looking out at the stars and wondering if anyone else is looking back. Unless, and this is where it gets interesting, unless we're thinking about it wrong. What if the universe's vastness isn't a barrier? What if it's an invitation? Here's what I mean. If the universe is truly infinite, or close to it, then somewhere out there, in some distant region of space we'll never observe, there are civilizations far older and more advanced than us. Civilizations that have had billions of years to develop technology, to understand physics more deeply, to manipulate space-time in ways we can't imagine. Maybe they've figured out how to exceed light speed. Maybe they've discovered wormholes or warp drives or dimensional shortcuts. Maybe they've learned to communicate across cosmic distances using quantum entanglement or some other phenomenon we haven't discovered yet. Maybe the vastness of the universe isn't a prison. Maybe it's a proving ground. Maybe the civilizations that survive, that thrive, are the ones that develop the wisdom and technology to overcome the isolation, to reach across the void and make contact. And maybe humanity can be one of those civilizations. But here's the catch. We're not there yet, not even close. We've barely left our planet. We've sent 12 humans to the moon, and nobody's been back in over 50 years. Our deepest space probes, Voyager 1 and 2, have been traveling for nearly half a century and have only just left the solar system. At their current speed, they'd take about 75,000 years to reach the nearest star. We're babies in cosmic terms. We've only just opened our eyes and looked up at the night sky with technological instruments. We've only just begun to grasp how vast and strange the universe really is. But we're learning fast. In my lifetime, we've gone from knowing of 0 planets outside our solar system to confirming thousands. We've gone from crude telescopes to Webb, which can analyze the atmospheres of distant worlds and look back to the dawn of time. We've gone from science fiction speculation about the universe's size to hard data showing us that everything we thought we knew was wrong. If we can progress this far in a few decades, imagine where we'll be in centuries, in millennia, in millions of years, if we survive that long. Maybe one day, our descendants, whether biological humans or our AI successors or something we can't currently imagine, will look back at this moment, at Webb's impossible galaxies, and smile at how limited our understanding was. Maybe they'll have unraveled the mysteries we're currently grappling with. Maybe they'll have developed technologies that make the universe's vastness traversable. Or maybe they'll have discovered that the universe is even stranger than we currently think. Maybe every answer leads to deeper questions, and the cosmic mystery never fully resolves. Maybe that's the point. But whatever the future holds, this moment right now, as Webb reshapes our understanding of cosmic scale, is historic. You're living through it. You're part of the species that looked too far and found the universe was bigger and stranger than anyone imagined. And that brings us to perhaps the most important question of all. What should we do with this knowledge? So we've established that the universe might be vastly larger than we thought, that our observable bubble might be an infinitesimal fraction of the cosmic totality, that we might be one of countless civilizations scattered across an infinity too vast to comprehend. The question is, so what? How should this knowledge change our behavior, our choices, our priorities as individuals and as a species? Let me start with what I think is the wrong response: fatalism. The idea that because we're so small, so brief, so cosmically insignificant, nothing we do matters. That's seductive in a way. It relieves you of responsibility. If nothing matters, then you can't make wrong choices. You can't fail in any meaningful sense. But it's also profoundly life-denying. And worse, it's logically inconsistent. Because if cosmic insignificance made things meaningless, then the universe's vastness would make itself meaningless. But the universe is what it is, regardless of what we think about it. It doesn't need our validation to matter. And neither do we. Here's what I think is the right response: cosmic humility combined with fierce determination to matter anyway. Yes, we're small. Yes, we're brief. Yes, the universe is so vast that our entire civilization, our entire planet, our entire galaxy could vanish tomorrow, and the cosmos would barely notice. But you know what? We notice. We care. We create meaning through our consciousness, our relationships, our efforts to understand and improve the world around us. The universe doesn't care if you're kind to someone today, but the person you're kind to cares. Their day is better because of you. That's real. That matters. The universe doesn't care if we cure cancer or end poverty or create art that moves people to tears, but we care. And that's enough. Meaning doesn't have to be cosmic to be real. It just has to be felt, experienced, enacted by conscious beings. And here's the beautiful thing. In a universe this vast, consciousness itself might be the rarest, most valuable phenomenon of all. Stars are common. Galaxies are common. Even planets are probably common. But consciousness? The ability to observe, to think, to care, to create? That might be extraordinarily rare. Which means that you specifically are participating in something precious. You're one of the universe's ways of knowing itself. You're a node of consciousness in a mostly unconscious cosmos. And that's remarkable. So what should you do with Webb's revelation about the universe's true size? First, let it expand your perspective. When you're stressed about small things, traffic jams, social media drama, petty conflicts, remember that you're on a tiny planet orbiting an average star in an unremarkable galaxy in a universe so vast it defies comprehension. That doesn't make your stress unreal, but it does contextualize it. It helps you distinguish between what actually matters and what's just noise. Second, let it inspire you to contribute something meaningful. You're here right now, in this cosmic moment. You have a brief window of existence. What are you going to do with it? How are you going to make the world, your little corner of this vast universe, better than you found it? You don't have to cure cancer or end world hunger. You don't have to be Einstein or Gandhi. You just have to do something. Create something. Help someone. Learn something. Teach something. Make the tiny bubble of space and time you occupy a little brighter, a little kinder, a little more interesting than it would have been without you. Third, let it fuel your sense of wonder and curiosity. Webb is showing us that the universe is stranger than we imagined. That means there's still so much to discover, so much to learn, so many mysteries waiting to be unraveled. Stay curious. Keep asking questions. Never lose that childlike wonder at the sheer existence of everything. And fourth, let it connect you to something larger than yourself. You're not separate from the universe Webb is revealing. You're made of it. Your atoms were forged in stars that lived and died billions of years ago. You are literally stardust that learned to think. You're a brief eddy in the cosmic current, a temporary pattern that will eventually dissolve back into the universal flow. But while you're here, while you're conscious and aware, You're participating in something extraordinary. You're the universe experiencing itself. You're matter that became complex enough to contemplate its own origins and fate. That's not nothing. That's everything. Now, I want to address something that might be bothering you. You might be thinking, okay, this is all very poetic, but it's also kind of depressing. You're telling me the universe is so vast that we'll never explore it, never meet other civilizations, never transcend our tiny corner of space. We're alone and insignificant and doomed to a brief existence on a small planet before we're forgotten forever. How is that inspiring? Fair question. And you're right that there's a melancholy to cosmic awareness. Once you truly grasp the scale of space and time, it's hard not to feel small and temporary. But here's the reframe. You are small and temporary, but so is everything. Stars die. Galaxies collide and disperse. Even black holes eventually evaporate through Hawking radiation. Nothing lasts forever. Nothing is permanent. So the question isn't, how do I make a permanent mark on an eternal universe? Because you can't. The question is, how do I live well in the brief time I have? And the answer to that question doesn't depend on the size of the universe. It depends on how you choose to engage with the life you've been given. Dr. Alan Lightman, physicist and author, wrote something beautiful about this. He said that the impermanence of everything, the fact that we're all temporary patterns in an ever-changing cosmos, makes our moments of consciousness and connection more precious, not less. We have this brief window to experience beauty, to love, to learn, to create. The fact that it ends doesn't diminish it. It intensifies it. Think about a sunset. It's beautiful precisely because it's fleeting. If the sun hung motionless in the sky forever in its golden hour glory, we'd stop noticing it. The beauty is in the transition, the temporary moment of perfect light before night falls. Your life is like that sunset. Brief, temporary, but beautiful because of it, not despite it. And here's something else to consider. While the universe might be too vast for us to explore it all, we can still explore our corner of it. We can still learn about the cosmos through our telescopes and our mathematics. We can still create meaning in our relationships and our communities. We can still push the boundaries of knowledge and technology, even if we never exceed the speed of light. The journey matters as much as the destination, maybe more. And who knows? Maybe we're wrong about the limits. Maybe there are ways to traverse vast cosmic distances that we haven't discovered yet. Maybe civilizations thousands or millions of years more advanced than us have figured out tricks we can't currently imagine. The universe has surprised us before. It's surprising us now with Webb's discoveries. It'll probably surprise us again. So while it's important to be realistic about our limitations, it's also important to stay open to possibilities, to remain humble in the face of cosmic vastness while also being audacious in our ambitions. Because here's the thing, humanity has always exceeded expectations. We're the species that looked at the sky and figured out we're on a spinning ball orbiting a star. We're the species that split the atom and walked on the moon and sent robots to Mars. We're the species that built the James Webb Space Telescope and pointed it at the edge of the universe and found galaxies that shouldn't exist. We're pretty remarkable when you think about it. Not cosmically significant, maybe, but remarkable nonetheless. And we're just getting started. All right, we've covered a lot of ground. We've talked about impossible galaxies, infinite universes, quantum observation, the Fermi paradox, and the meaning of existence in a cosmos too vast to comprehend. But there's one more aspect of Webb's discoveries that we need to discuss, and it's perhaps the most unsettling of all. It has to do with the ultimate fate of the universe. Because if Webb is showing us that the universe is bigger than we thought, it's also giving us clues about how it will end. And the implications are, well, they're bleak, but in a strangely beautiful way. Here's what we know. The universe is expanding. Not just the objects in the universe moving apart, but space itself is stretching, growing, carrying galaxies away from each other at ever-increasing speeds. This has been known since the 1920s, when Edwin Hubble first measured the redshift of distant galaxies. But here's what was discovered in 1998, in research that eventually won the Nobel Prize. The expansion is accelerating. The universe isn't just getting bigger. It's getting bigger faster and faster over time. Something is pushing space apart with ever-increasing force. We call that something dark energy, but that's really just a label for our ignorance. We don't know what dark energy is. We just know it exists because we can see its effects. And those effects are profound. If the expansion continues to accelerate, and all our observations suggest it will, then eventually everything in the universe will be pushed so far apart that no galaxy will be able to see any other galaxy. The expansion will carry distant galaxies away from us faster than light can travel from them to us. They'll disappear beyond our cosmic horizon, one by one, until we're left in the island universe, alone with just our local group of gravitationally bound galaxies. And it gets worse. Eventually, even the stars in our galaxy will run out of fuel. The universe will become cold, dark, and empty. All structure will dissolve. All complexity will fade. All consciousness, if any remains, will wink out into eternal night. This is called heat death, or the Big Freeze, and it's the most likely end state of our universe. Not a catastrophic collapse or a violent explosion, but a slow fade into increasing entropy, disorder, and darkness. The universe will expand forever, getting colder and emptier and darker, until nothing interesting can happen anymore. It's depressing, sure, but here's where Webb comes in with a twist. Those massive early galaxies, the impossible ones that shouldn't exist, they're giving us clues about dark energy. Because their existence, their distribution, their properties, all of it is sensitive to the expansion rate of the universe. If dark energy behaves differently than we think, if the acceleration isn't constant, if there are variations across cosmic scales, then the galaxies we observe would look different. And they do look different. They look impossible, which suggests that our models of dark energy and cosmic expansion might be wrong. Some cosmologists are now proposing that dark energy might not be constant. It might vary over time or across space. In some models, dark energy could even reverse, turning from a repulsive force into an attractive one. If that happened, the expansion would stop, then reverse. The universe would begin contracting, pulling everything back together until it all compressed into a singular point again, a big crunch. And in cyclic models like Dr. Steinhardt's, that big crunch would be followed by another Big Bang, starting the whole process over. The universe would bounce eternally between expansion and contraction, creating and destroying itself in an endless cosmic rhythm. If that's true, then the heat death isn't inevitable. The end is really just another beginning. The universe we live in is just one phase in an eternal cycle. And all the structure, all the complexity, all the consciousness that seems doomed to fade away will return in the next cycle, in new forms, exploring new possibilities. It's a kind of cosmic reincarnation. And it suggests that the universe's size isn't growing toward infinity. It's oscillating, breathing in and out across timescales so vast that our entire current universal epoch is just one breath. Now, I have to be honest, we don't know if this is true. The cyclic model has problems. There are questions about entropy. How does the universe reset itself? About causality, what happens at the bounce point? About observations, can we find evidence of previous cycles? But the fact that Webb's impossible galaxies are making us take these models seriously is significant. It means our understanding of cosmic fate is uncertain. It means the story might not end with a whimper in the cold darkness. It might end with a reset, a renewal, a return to the beginning. And that changes the emotional weight of cosmology. Instead of a tragedy existence, briefly flickering in an eternal void, we get something more like a saga. An endless story of creation and destruction, of complexity emerging from simplicity, of consciousness arising from matter, of the universe knowing itself through countless iterations. Dr. Roger Penrose at Oxford has proposed something even stranger called conformal cyclic cosmology. His idea is that the heat-death, the cold, empty, dark endpoint we're headed toward actually becomes identical to the hot, dense, energetic state of a new Big Bang when you account for certain properties of space-time geometry. The end and the beginning are the same state, viewed from different perspectives. In his model, the universe doesn't contract and crunch. It just transitions. The infinitely distant future of one cosmic epoch becomes the Big Bang of the next. Time itself loops back, not in a circle, but in a more complex topological structure that allows for eternal recurrence without literal cycling. It's wild, it's speculative, but it's also beautiful. And it might be true. And if it is true, then asking about the universe's size is asking the wrong question in an even more profound way than we discussed earlier. Because the universe isn't just big in space. It's big in time. Infinitely big, possibly, extending both backward and forward without end. You and I, sitting here in 2026, are just one brief moment in an eternal cosmic story. Our universe, with its galaxies and stars and planets and life, is just one chapter in a book that has no first page and no last page. And every impossible galaxy Webb finds is a clue to the larger narrative. A hint that the story is stranger and longer and more complex than we ever imagined. So what does that mean for how we should live? For what matters? Here's my take. If the universe is eternal, if existence goes on forever in some form, then the specific details of our lives become both infinitesimally small and infinitely precious. Small because they're brief moments in an endless story. Precious because they're unique, unrepeatable, never dash to dash occur dash, again in dash exactly dash this way moments of consciousness and experience. You are not just living your life. You're contributing to the universe's eternal exploration of possibility. Every choice you make, every thought you think, every person you touch is adding to the cosmic story. And even if your specific contribution is forgotten, even if your name fades from history and your atoms disperse back into the cosmic wind, the fact that you existed, that you were conscious, that you cared, it becomes part of the eternal pattern. You are a note in an infinite symphony. Brief, yes, but necessary. Remove any note, and the music changes. You change the music by existing, and that's beautiful. We're in the final stretch now, and I want to bring this all together into something practical, something you can hold on to when you finish listening to this and go back to your regular life. Because the danger with cosmic thinking is that it can become paralyzing. You start contemplating the vast universe, your own insignificance, the heat death of everything, and suddenly it's hard to care about paying your bills or doing your job or being kind to your neighbor. If nothing matters cosmically, why should anything matter personally? But here's what I've learned, both from studying cosmology and from living as a human in the world. The cosmic and the personal aren't opposed. They're complementary. Understanding the vast impersonal universe makes the personal connections more precious, not less. Let me give you a concrete example. Right now, as you're listening to this, you're having an experience. You're thinking thoughts, feeling feelings, maybe looking around the room you're in or the landscape you're passing through. This moment right now will never happen again. Not exactly like this. Not with these specific thoughts and circumstances and contexts. In a few hours, this moment will be a memory. In a few years, you'll have forgotten most of the details. In a few decades, you'll be gone, and this moment will be gone with you, lost to time like tears and rain, as the saying goes. But right now, it's real. It's happening. You're conscious and aware and alive. And the fact that the universe is vastly larger than this moment doesn't make this moment less real. If anything, it makes it more precious. Because in all that vast cosmic space, In all those billions of galaxies and trillions of stars and potential infinities of worlds, this specific moment is happening here, now, to you. That's remarkable. And here's what's even more remarkable. You can choose what this moment means. You can choose how you respond to Webb's revelation about the universe's size. You can let it make you feel small and insignificant, or you can let it make you feel connected to something vast and beautiful. You can let it paralyze you with existential dread, or you can let it liberate you from petty concerns and inspire you to engage more fully with life. The universe doesn't care what you choose, but you should care, because your subjective experience, the quality of your consciousness, the richness of your engagement with life is all you have. It's your entire reality, and you have more control over it than you might think. Dr. Viktor Frankl, who survived Nazi concentration camps and went on to found logotherapy, wrote that humans can't always control their circumstances, but they can always control their attitude toward their circumstances. He found meaning and purpose in the most meaning-destroying situation imaginable, and he did it by choosing how to respond. You're in a much better situation than Frankl was. You're, presumably, safe, fed, free to think and explore and question. And you've just learned something profound about the nature of reality. The question is, how will you respond? Here's my suggestion. Use Webb's revelation as a reminder of perspective. When you're caught up in stress or anxiety or conflict, take a moment to zoom out. Remember that you're on a planet orbiting a star in a galaxy containing hundreds of billions of stars. And that galaxy is one of hundreds of billions of galaxies in the observable universe. And the observable universe might be an infinitesimal fraction of the cosmic totality. That doesn't make your problems unreal, but it does put them in context. It helps you distinguish between what's truly important and what's just temporary static. And then, having gained that perspective, zoom back in. Focus on what you can actually affect, your relationships, your work, your local community, your own growth and development. You can't change the universe, but you can change your corner of it. And that's enough. Here's something else to consider. Webb's discoveries are a gift from the past to the future. The telescope was decades in development. Thousands of scientists, engineers, and technicians worked on it. Many of them won't live to see all the discoveries it makes. But they built it anyway, knowing it would benefit future generations. You can do the same thing. You can contribute to something that outlasts you. Not a telescope, maybe, but something. A family, a work of art, an idea, a kindness that ripples forward through time in ways you can't predict. You don't have to be cosmically significant to be significant to someone. You don't have to be eternal to have an impact that echoes into the future. And finally, stay curious. Webb is rewriting cosmology right now, showing us things we can't explain, forcing us to question our most fundamental assumptions. And that process will continue. We're in the middle of a scientific revolution, and nobody knows where it will lead. Maybe we'll discover that the universe is even stranger than we currently think. Maybe we'll find evidence of other dimensions, parallel realities, cosmic structures that transcend our current understanding. Maybe we'll make contact with other civilizations and discover we're not alone after all. Maybe we'll develop technologies that let us traverse the cosmic distances and explore the vast universe Webb is revealing. Or maybe we'll discover that the mysteries are deeper than we thought, that every answer leads to 3 more questions, that the universe is fundamentally inexhaustible in its strangeness and complexity. Either way, there's adventure ahead. There are discoveries waiting to be made, and you get to witness some of them, maybe even contribute to them in small ways. That's not a burden. That's a privilege. So here's what I want you to take away from this. The universe is vast beyond comprehension. You are small in grief, but you are also conscious, aware, capable of wonder. You are the universe's way of knowing itself. And in a cosmos that might be mostly unconscious, that's extraordinary. Webb looked too far and found that the universe is bigger than we thought. But it also found something else, that we're capable of looking that far, that we're capable of asking deep questions and finding surprising answers, that we're capable of being humbled by cosmic scale while still having the audacity to try to understand it. We're remarkable. You're remarkable. Not because you're cosmically significant, but because you exist at all. Because consciousness exists at all. Because in all that vast space and time, there are pockets of organized complexity, like you, like me, like all of us, briefly defying entropy and creating meaning and beauty and understanding. And that's worth celebrating. So let me bring this to a close with a final thought, a final reframe of everything we've discussed. The James Webb Space Telescope looked deeper into space and time than any instrument before it. It found galaxies that shouldn't exist according to our models. It revealed structures that violate our assumptions. It showed us that the universe is bigger, older, stranger, and more complex than we ever imagined. And in doing so, it gave us a gift. Not just new data or new discoveries, but a new perspective. A reminder that reality is larger than our theories about it. That the map is not the territory. That our models of the cosmos, no matter how sophisticated, are still just models, simplifications of something too vast and complex to fully capture. This is humbling, yes, but it's also liberating, because it means we don't have to have all the answers. We don't have to understand everything. We can be comfortable with mystery, with uncertainty, with the knowledge that there's always more to discover. And that opens up space for wonder, for curiosity, for the joy of exploration without the burden of needing to reach a final destination. The universe's true size might be infinite. It might be finite but unbounded. It might be one of many in a vast multiverse. It might be oscillating through eternal cycles. We don't know, and that's okay. What we do know is that we're here, now, able to contemplate these questions, able to build telescopes and look back to the dawn of time, able to do mathematics that describes the curvature of space-time, able to create art and music and stories that give meaning to our brief existence. We're conscious matter, stardust that learned to think, the universe observing itself. And in a cosmos that's mostly empty space and unconscious matter, that's the rarest and most precious thing of all. So when you go about your day tomorrow, when you're stuck in traffic or doing chores or working at your job, remember, you're doing all of that on a planet that's hurtling through space at hundreds of kilometers per second, orbiting a star that's orbiting the center of a galaxy that's falling toward other galaxies in a universe that's expanding into, we don't even know what. You're part of the most astonishing story ever told. The story of how matter became aware of itself, how the universe achieved consciousness, how complexity emerged from simplicity, how meaning arose from meaninglessness. And you get to be part of that story, not as a passive observer, but as an active participant. Every choice you make, every thought you think, every person you touch is adding to the cosmic narrative. You matter, not because you're cosmically significant, but because you're conscious, because you care, because you create meaning through your existence. And the universe, vast, ancient, mysterious as it is richer for having you in it. Webb looked too far and found that the universe is bigger than we thought. But it also found something else, that we're capable of looking that far, that we're capable of being surprised, that we're capable of having our entire worldview shaken and still having the courage to keep exploring, keep questioning, keep seeking truth. That's not insignificant. That's heroic. So thank you for listening to this journey through cosmic space and time. Thank you for caring enough about the universe to want to understand it better. Thank you for being the kind of person who looks up at the stars and asks the big questions. The universe is vast beyond comprehension, but you're part of it. You're made of it. You are it, experiencing itself through human form. And that's the most beautiful truth of all. Now, one last time before we end, if this script expanded your mind, challenged your assumptions, or gave you a new perspective on existence, hit that like button. Subscribe to the channel and drop a comment telling me what aspect of Webb's discoveries surprised you the most. Because this conversation doesn't end here. This is just the beginning of humanity's new understanding of cosmic scale. We're all in this together, all of us conscious beings scattered across a universe bigger than we can imagine. Briefly awake in the cosmic night, trying to understand where we are and what it all means. And even if we never find final answers, the search itself, the exploration, the wonder, the shared human project of trying to comprehend reality, that's what makes life worth living. Thank you for being part of that search. Thank you for existing. And thank you for looking up at the stars and daring to ask, how far does it all go? Webb looked too far, and what it found will echo through human consciousness for generations to come. The universe is vast. You are brief, but you are here now aware of the vastness. And that changes everything.